Now we start looking at reactions in our chemistry unit. So we're actually going to start taking a look at an actual chemical process, a chemical reaction, and we're actually going to look at the number of atoms of each element that we're starting with and ending with. Basically, you can think of any chemical reaction like a recipe. So here's a recipe for some s'mores. You take 2 cracker squares and a marshmallow and some chocolate squares, and you can put them together and make a s'more. And the idea is we have a ratio of a 2 to 1 to 3 ratio to make one s'more. Now, at the end of the reaction, you still have all the parts that you started with. They're just rearranged in a different way. Chemical reactions are a lot like playing with Lego. You put all the Lego pieces together to build one thing. If you take those same pieces, take them apart, and put them together in a different way and build something different, that's what a chemical reaction is. You're just taking the atoms apart and putting them all back together in the same way. And this is something that we call the law of conservation of mass, and we'll get to that in a second. So remember that a chemical reaction is where elements or compounds are being mixed, and you get a chemical change happening where some sort of a new substance with new properties is being produced. Remember that chemical reactions produce something new, and physical changes or physical reactions don't. You start and end with the same substance. A chemical reaction will always involve the breaking and making of bonds between the atoms. So you're making new bonds. And remember, bonds result from the giving and or taking of electrons, or even the sharing of electrons. So all we're doing is we're rearranging things to put them together in a different way. Now, all bonds will result from the giving and taking electrons. That's an ionic bond, or the sharing of electrons, a covalent bond. So here's an example of a reaction. You have hydrogen gas over here, you have oxygen gas here, and you're making waters. Now, if you look on both sides of this reaction, what you end up with is, or what you start with is H2 here and H2 here. So you have a total of 4 hydrogens here and 2 oxygens. On the other side, you have 1 oxygen and 2 hydrogens, and another oxygen and 2 hydrogens. So the number of hydrogens and oxygens on both sides of the reaction are still the same, because you don't magically create hydrogens or oxygens, you're just rearranging the atoms that you have. So a chemical reaction always shows us this process that the substances react by to produce some sort of a new substance. And all the equations will have a general formula, and that formula always looks like this. You have reactants forming products. You'll notice that we don't use an equal sign, because reactants and products are not equal to each other, but reactants make products. So what you should see is that there's this arrow right here it means yields, like that. And what yield means is to give way to. So like if you're driving, we've seen yield signs on the street. That yield sign means give way to. So you give the right of way to whatever car is on the other side of the yield sign. So you yield to that other car. So reactants will yield products. In other words, they give way to products. Reactants are what you start with, they're your ingredients, and your products are what you're making. The arrow means produces or yields, that's what I just said. The reactants are always on the left side, so we always work from left to right, and the products are always on the right side of the arrow. So here's another example, the same reaction I just showed you, H2 and O2 makes H2O. Now, you will see reactions in a couple different ways. You can see them as a word equation where we say oxygen and hydrogen produce water, or you can see it as a balanced chemical equation where you actually have the elements or the compounds, the formulas. So O2 plus 2 H2s makes 2 H2Os. Now, chemical equations that are not balanced, so this one's a balanced one, because you'll see what I mean in a minute. We usually just call them Skelton equations, and you'll have to balance it. So all the compounds will be there, but we just have to actually go back and figure out how many things are on each side. Now that brings us to something called the law of conservation of mass, and that's probably the most important concept that chemists use. We use it all the time, and this is basically it. Matter cannot be created or destroyed. You can't just magically make something from nothing, and you can't make something that you had just disappear into thin air. It just doesn't work that way. So what this means is the total mass of your reactants is always equal to the total mass of your products. So here's an example of a reaction. If we're burning wood, you see we react wood with oxygen gas, and we're going to make carbon dioxide and ashes and water vapor. If we started with, let's say, 500 grams of stuff on this side, we would still end with 500 grams of stuff on that side, because all of the carbons, oxygens, hydrogens, and carbons in the ash, all of that stuff still is there. It's just been rearranged. All of these atoms and elements are part of this or come from this. So that we've taken the Lego pieces apart and we've built a few different things with them. All the pieces are still there though. So here's an example. You have CH4 and O2. This is actually the reaction for using a Bunsen burner. This is the reaction of methane with oxygen. And if you look on the reactant side, you have 1 carbon, you have 4 hydrogens, and you have 2 oxygens. Now on the product side, you have 1 carbon, you have 2, and 1 makes 3 oxygens and 2 hydrogens. So if you look, the carbons are the same. We didn't gain or lose carbons. But if you look at the hydrogens, we started with 4 and we ended with 2. That's not good, because now we've somehow magically lost a couple of hydrogens. And then oxygens, we started with 2 and we end with 3. That's not good, because somehow we magically created an oxygen out of nothing. So that can't happen. So if that happens, your mass would have changed, right? Because you actually end up with different amounts of things on each side, which means your mass would change. So to keep that mass constant, we must have the same number of atoms on both sides so that everything stays the same, and our equation is what we call balanced. If something is balanced, if you think about like a teeter-totter, if a teeter-totter is balanced, you have the same amount of mass on both sides of the teeter-totter. So what does that mean? Well, in a balanced reaction, everything is the same on both sides. You have the same amount of things on both sides, which means you have the same mass. But in an unbalanced equation, you don't have the same mass. So to balance our equations, we use something called a coefficient. So we use subscripts. This is a subscript that tells us how many hydrogens there are, but this is a coefficient. And what that coefficient does is it tells me that instead of having just 1 water molecule, I have 2 water molecules. So that allows me, instead of writing the formula for water 2 times, I can just say I have 2 of them. Just like in math, if you say you have 2x, you literally have 2 x's. X and x makes 2x. If you have 10x, you have 10 x's. So basically what we're doing is so we don't have to write the same thing over and over and over again. We can just write it like that. So this indicates that there are 2 molecules of water. So using our example from before, going back to this, we can add coefficients in front to make, in front of the oxygen and the water, to make this reaction balance. So we want to make our hydrogens and oxygens match up on both sides. So to do that, what I can do, let's start off with the hydrogens. There's 4 hydrogens here. So to get 4 on the other side, I'm going to times this side by 2. So I'm going to put a 2 in front. I'm going to make 2 water molecules, and that will help make the hydrogens, number of hydrogens, the same on both sides. And then now, if you look, I have 2 oxygens here, and 2 times 1 is 2 oxygens there, so that's 4 oxygens. So if I put a 2 here, if I have 2 oxygen molecules, so I'm going to times this one by 2, that will make the amount of oxygens the same on both sides as well. And that's how we add our coefficients in. So here's my 2 there and my 2 there, and now my equation is balanced. If you look, we have a carbon here, oxygen, 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 oxygen. There's a carbon here, oxygen, 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 oxygen. And then I've got my 4 hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. There's my 4 hydrogens. Everything adds up to the same on both sides. And that's what creates a balanced equation. Now, there are some steps to balancing. Most of this is kind of guess and check. The first thing we got to do is you actually have to have a reaction to balance. So if I give you a word equation, so like sodium metal reacts with chlorine gas to produce sodium chloride, we actually have to figure out what the products and the reactants are. So the 2 things that are reacting, sodium metal is combining with chlorine gas. So that will be our reactant, or those will be our reactants. And then sodium chloride, it tells me is being produced, so that's my product. Then what we're going to do is we're going to take those equations or those formulas and we're going to put them into an equation. Again, reactants on this side and products on that side. Now, when we write the equations, we still follow all of the rules for equation writing and naming that we've done before. So sodium is Na, chlorine gas is Cl2, Hofbrinkel, and then NaCl, sodium chloride, is Na and Cl. It's a 1 plus 1 minus. So we still have to use all those charges and things. Make sure everything adds up to 0, everything we've been doing so far. Our diatomic molecules, that's what I'm saying. So chlorine has to be Cl2, and so on and so forth. So once we've got that, we're going to make a list. So on the reactant side and the product side. So let's look at the reactant side. There's one Na here, and there are 2 Cl's here. On the product side, I have one Na, and I only have 1 Cl. So we have to make this work so that I have the same amount of each element on each side. So I need to double the chlorines. How can I do that? Well, you cannot put a 2 there. That is not the formula for sodium chloride. You're not allowed to change the little numbers because, remember, if I have that and I change it to that, and now people can die because it's not water anymore. So we're not allowed to do that. We need to put a coefficient. So when we're balancing, we can only use coefficients to balance. So I put a 2 in front, which means I've also doubled this. So I've got 2 sodiums and 2 chlorines on this side. Now, on the other side, my chlorines are now balanced, but my sodiums are not. I can't put a 2 there because we don't change subscripts, but we can change the coefficient. So I'm going to put a 2 there, and that gives me 2. So now we're balanced. That's how we balance this equation. We have to balance our equations using whole numbers only. So we're not using fractions, not using decimals. They need to be a whole number. And our final result for this reaction would just be this. 2Na plus Cl2 makes 2NaCl. Now, there is a little bit of some tricks, I guess, of the trade, so to speak, of how to balance things and make it a little bit easier. If you can remember this acronym, this will help you. So here's our acronym, MACHO. If you can balance reactions using that word, you'll know what I mean. So M stands for metals, A stands for ametals. I'm going to put in brackets non-metals. And then it goes carbon, hydrogen, and then oxygen. If you follow this order, usually it'll make your balancing life a lot easier. In other words, you start at the top and you work your way down. Metals, then your non-metals, then your carbons, hydrogens, and oxygens. Try to leave the carbons, hydrogens, and oxygens till the end. And the rule that I always say is look for the easiest thing to balance and balance that first. So if I'm doing question number 1, or try this one, number 1, I'm not going to worry about the 2 hydrogens first. I'm going to leave that alone. Nitrogen looks like it would be really easy to balance because there's a 2 there. All I got to do is put a 2 here, and now my nitrogens are balanced. Now I'll worry about the hydrogens. 2 times 3, so I have 6 hydrogens on this side. So if I put a 3 there, now I have 6 hydrogens on that side. And now we're balanced. Same thing in the next one. So I'll follow the Macho rule. So metals, 1 manganese, 1 manganese, they are balanced. Now the other metal, copper, copper, 1 and 1, they are balanced. Now we go to the A metals. So now I'm going to look at my chlorines. Well, I got 2 here, but only 1 here. So I have to change that. I have to put a 2 in front. Okay, so now by doing that, I've actually changed my copper. So I'm going to go back and fix my metals. And if we leave it like that, we are now actually balanced. Okay, same thing for the next one. I'm going to do, actually, if we look, hydrogen's already balanced, so I'm going to jump to the oxygens. So I got 2 there. I need 2 waters to be made to have 2 oxygens. But in doing so, now I have to fix my hydrogens. All right, and then when you're getting into these ones are a little bit more complicated. When we get further on, I'll teach you what this SO4 business means. You can actually treat them as one whole thing, but for this part, we'll just separate them out into sulfurs and oxygens. So again, start with your metals. So barium and barium are balanced. Aluminum, the other aluminum is not, so I need a 2 in front. Okay, so bariums and aluminums are now balanced. Let's go to chlorines. So I've got 2 times 3 is 6, so I need a 3 in front of this. Well, that messes up my bariums, so I'm going to fix my bariums right now. And then now let's check so let's just go through and check everything. So 3 bariums, 3 bariums. I've got 2 aluminums, 2 aluminums. Now let's check our sulfurs. 3 times 1 is 3 sulfurs. 3 times 1 is 3 sulfurs, so that's good. And 3 times 4 is 12 oxygens, and 3 times 4 is 12 oxygens. So we are balanced. That's how you would do these. And really the ultimate, like the only thing that you can do to be able to do this better is just to practice. The more balancing you do, the easier and easier and easier it gets. You'll start to kind of find little tricks and start seeing little patterns, and it gets a lot easier. It's mostly guess and check. Sometimes this macho that will help you, just at least give you a process to follow along with.